Hi everyone, we are Group 11, Faik and Kemal, and this is our final project, single ball potting robot, as we call it, the rocket. Here you can see it in action. You can see it moves into the designated position, hits the white ball, and makes the 8 ball. Also, it turns back to its initial position, ready for the net shot. On the right-hand side, we have the software demonstration. For this project, we had several goals. Firstly, we wanted a fully autonomous system. Also, we wanted it to look aesthetic for the user. We needed high precision and accuracy, especially for simpler shots. Finally, we wanted a compatible and reliable hardware-software integration. Here you can see the overall flow of our system. We have a hardware and the software parts. A camera we mounted on top of the pool table takes an image and sends it to a computer. Here we do some image processing and detect the positions of the balls. Using this data, we do some trajectory calculations for the cue ball and send this data to the robotic arm using Arduino. And finally, the robotic cue executes the shot. Here I will give some more detail on the previous slide. Firstly, we acquire live images using MATLAB mobile app and apply 5 main steps to these images prior to modeling calculations. These steps are camera calibration to obtain the camera parameters, and using the camera parameters, we then undistort the image to get better results. Next up, we use a checkerboard image to obtain a relative 2D coordinate system. And using the built-in MATLAB function, we find and differentiate balls. Finally, we transform image coordinates, pixels, into world coordinates, millimeters, for better modeling purposes. For modeling, we first select the optimum hole to shoot the ball using a MATLAB algorithm that selects the straightest shot, as you can see on the left-hand side. And then we use ghost ball aiming method, as you can see on the right-hand side, to find the trajectory of the cue ball. Basically, the center of the cue ball, object ball, and the selected hole should all lie on the same line.
In order for us to build the hardware and the skeletal structure, we use the component as displayed in this slide. Also, in order for us to communicate between the MATLAB and Arduino, we used serial communication data coding so that we could transfer the initial and designated positions of the solenoid that is to be striked. Here you can see the solenoid and the robotic arm and its components on the left-hand side. On the right-hand side, you can see some calculations that we did to determine the right solenoid with the right striking force according to its gap distance using pull force versus plunger position graph. Here you can see some of the trials we did. We initially did 40 trials with different scenarios of different ball positions. On the right-hand side, you can see the image processed in real life to the digital system and the coordinates that the solenoid takes to the designated path. On the very right-hand side, you can see the accuracy rates and the reasons behind the missed shots is that the pool table has a rough and inclined surface. Even though the solenoid takes the designated path and strikes the ball in the same correct path, the force is not enough to further the object ball to the pockets, and we have some larger angles that makes the shots even more difficult. For our future work, we plan to do a multiple ball potting software upgrade if we continue on this path. Also, for increased precision and accuracy, we should try out the harder shots and designated problems there and fix them. Also, interactive game experience for commercial use can be applied. Here are our acknowledgements. Thank you for listening. You can enjoy the short demo edit that we prepared for you now.
To win a tournament, incredibly, he's even got a wry smile on his face. This is a genius at work. He knows he's got it now. Everybody in the room, and Ding Junhui, he's won the Bet Victor Welsh Open. This audience has gone absolutely berserk. There's standing ovation throughout the crowd.